So for the rest of section 2 deals with dimensional analysis. And this again is something that you will use all year long. When we get into what is called stoichiometry, where we convert grams to moles and things like that, this will be huge. If you take advanced chemistry, we do thermochemistry, and even in regular life situations, you're going to use this quite often. So dimensional analysis is a systematic approach to problem solving. So that's why you're probably going to use it no matter what. It uses conversion factors to change from one unit to another. So a conversion factor is anything that has a ratio of equivalent values. So for example, one conversion factor, 12 donuts, is exactly the same as what? 1 dozen donuts. That is a conversion factor. 60 minutes is exactly the same as 1 hour. That is a conversion factor. 1 meter is the same as 1,000 what? Millimeters. That's a conversion factor. 0.001 millimeters is the same as 1 meter. That's a conversion factor. So conversion factors are equivalent. They mean the same thing, but we're going to use them in different ways. I like to use I like to use 1,000 milliliters, 1,000 meters, 100 centimeters. From your table, you can also use your decimals. So it doesn't matter which way you go, as long as you're using two things that are the same. So I could say that one chemistry class. Do you guys have a question?
Wouldn't it be 1,000th meter is the same as 1 millimeter?
How is 0.001 millimeters equal 1 meter?
I should have had I should have had 1,000th meter.
Oh,
Yeah.
okay.
You
Is
had
the same
1
as-
meter and then 1 meter.
I had the one with the meter?
Yeah.
Alright, then I just labeled it backwards. Okay. So conversion factor, they have to be equal. I could have one chemistry class is 11, normally 11. So one chemistry class is 11 students. I could have one chemistry class is 80 minutes, as long as they're equivalent and they mean the same thing. So to use those, here's the dozen thing. Percentages can also be used, can go to 100 total like a percentage does. So here, I'm thinking graduation. I used dimensional analysis when kids graduated, when Logan got married. If I have 32 people, I know 2 bottles per person. I can buy 8-pack of bottles. I can figure out how much of something to buy. And I'll do a couple more examples. So there's a real life example. Pizza. Buying pizza would be another way. So, here we go. Ancient Egypt. Mr. Flatten would be proud. Small distances were measured in cubits. An Egyptian cubit, so 1 cubit, was equal to 7 palms. That's one conversion factor I can read. 1 palm was equal to 4 fingers, and I abbreviate. And 1 finger was equal to 18.75 millimeters. So here it's given me conversion factors. Now it's asking me my question. Convert 6 cubits to meters. 2 rules. Start with what you have. So I'm converting what?
It's 2 meters.
I'm converting 6, so that's what I'm going to start with. I have 6 cubits. Step 2, you want to know, what am I looking for? What is it asking me to find? Meters. Okay, I'm going to totally look at labeling. So 6 cubits, which conversion factor has cubits in it? Okay, so cubits has to go where? On the bottom, because I want that to cancel. I can go from cubits to palms. So now using my factor, 1 cubit is the same as 7 palms. If I did my math right now, my answer would be in what? Palms, because that's the only label I have left. Is that what I'm looking for? Nope, so I'm not done yet. I want to get rid of palms, so I'm going to put that on the bottom. What can I change palms to?
Fingers.
Okay, so if I look at that, in 1 palm, there's 4 fingers. If I did my math now, my answer would be in fingers, so I'm not done yet. I have to get rid of fingers. And I can change that to millimeters. So I'm going to actually give myself a little bit more room. So I want fingers to millimeters. And if I look at that, 1 finger is the same as 18.75. Cancel, cancel. Am I done?
No.
No, I need to change millimeters to meters. And I do, in 1 meter, how many millimeters are there? 1,000. Or, if you like to use the table, I could do 1 millimeter, so my millimeter is still on the bottom, and I could put my 001 meters on top. I like to use that one, so that's the one that I will use. Now, I have canceled everything but my meters. That's my answer. That's what I'm looking for. So I am going to take 6 times 7, because it's on the top, times 4, times 18.75, times 1, if you want to actually do that, divide by 1, divide by 1, divide by 1, divide by 1,000. I ignore my ones, so I would take 6 times 7 times 4 times 18.75 and divide by 1, or divide by 1,000, sorry. Somebody tell me the answer that you get.
3.15.
3.15? And I would label that in? Okay, the last thing I have to do is go back, and we'll talk about this. I started with 6. That will affect my answer as we go on, but there would be an example. Let's say I am going to buy pizza for this classroom, which I'm not, but let's pretend. So today there are 10 of you. How many pieces of pizza will you eat? Average of 2. Anybody eat more than 2? I'd probably go with 3 to be safe. So I'm going to say that one person is going to eat 3 pieces. I know I'll have some leftovers, but that's okay. I'd rather have leftovers. What else do I need to know? How many people there are? How many are there? 10. There's 10 people. What else do I need to know? How many pieces in a pizza? So I'm going to order large, so most of them have 12 pieces. I should have wrote slices, but that's all right. In one pizza. What's probably the other thing I would want to know? How much it costs. So we're going to say one pizza is $10. Okay, so I have 10 people, and I want to know how much it's going to cost, which will also help me find out how many, or what do you guys want to find? You want to find the number of pizzas first? Let's just find pizzas. Okay, so dimensional analysis, what goes on the bottom, Austin? What do I have? What am I starting with?
You're one person, 2 pieces.
Nope, what am I starting with?
Oh,
10 people. What has to go on the bottom? People. I have to get rid of people. So I don't want people. What can I change people to, or person, I guess? 2 pieces. Oops. Pieces. So 1 people, 1 person, how many pieces? 3. Okay, now I can tell that we're going to eat how many pieces? 30. But that's not what I want. I want what? Pizza. So what goes on the bottom now, Austin?
1 person, 2 pieces.
So what goes on the bottom? What label goes on the bottom?
3 pieces.
Just pieces. The number doesn't go with it. Can I change pieces to pizza?
Yes.
Yes. So in 1 pizza, there are
12 pieces.
12 pieces. My pieces are canceled, people. Pizza, that's what I'm looking for. What am I going to do? 10 times 3, divide by 12. What do you get? 3.5. 2.5. Can I order 2.5 pizzas? You'll have to order what? 3. I'm going to get 3 pizzas. They each cost $10. I'm going to spend $30 buying pizza. So your labels, and I will want to see your work, your labels are very, very important when you set up anything to do with dimensional analysis. And then here's just the solving that we did already, so you have that in your notes if you want to go back and look at it. And then the last slide has your vocab, your essential questions, which, to be honest, the vocab, not very big, but make sure you know how to use all of these. Okay?